All right, let's solve now an AP free response problem involving integrated rate laws. This question came from the 2011 AP chemistry exam and reads as follows. A sample of ethanol gas and a copper catalyst are placed into a rigid, empty 1-liter flask. The temperature of the flask is held constant, and the initial concentration of the ethanol gas is 0.0100 molar. The ethanol begins to decompose according to the chemical reaction represented below. The concentration of ethanol gas over time is used to create the 3 graphs below. So if you look here from left to right, we have the concentration of ethanol versus time, 1 over the concentration of ethanol versus time, and the natural log of the concentration of ethanol versus time. Okay? So, letter A, given that the reaction order is 0, 1, or 2, use the information in the graphs to respond to the following. Part I, determine the order of the reaction with respect to ethanol. Justify your answer. So, the reaction is 0 order with respect to ethanol, and here's why. The 1 over ethanol versus time, this graph here, is not linear. This would be for a second order reaction. And the natural log of ethanol versus time is also not linear. That would be a linear reaction if it was a first order reaction with respect to ethanol. So the order of the reaction is 0. And what that means is that the rate is constant as the concentration of ethanol, I'm going to abbreviate ETOH, ethanol, changes. Okay? So the rate does not depend on the concentration of ethanol. We can see that actually here in the first graph. As the ethanol concentration decreases, it does so at a constant rate. Okay, so the rate is constant as the concentration of ethanol changes. All right, so part 2 here, II, says to write the rate law for the reaction. So if it is 0 order with respect to ethanol, remember that rate is equal to K times the concentration, but it's 0 order. Anything raised to 0 exponent is 1. So the rate is just equal to K. Rate is just equal to K. Okay, number 3, or part 3. I. Determine the rate constant for the reaction, including units. Okay, so I'm looking for the rate constant. So the rate is equal to K. Remember that the rate is minus change in ethanol concentration over change in time. So minus change in ethanol concentration. I'll just pick 2 points here. So let's pick the top and the bottom so that it's the easiest. So 0.0020 minus 0.0100 divided by 2,000 minus 0. It's just 2,000, and this is molarity. That's seconds. Okay, so just finding the slope there. So that difference is going to be negative. Then I have a negative here, gives me a positive. So K is 4 times 10 to the minus 6 molarity per second. Okay? Beautiful. So that's part A. Now, part B. Let me get rid of the ink on this page, make some space. Part B says, if the pressure in the flask at the beginning of the experiment is 0.40 atmospheres, If the ethanol completely decomposes, what is the final pressure in the flask? So here's the deal. Initially, we have 1 mole of reactant, which decomposes into 2 moles, 1 of CH3CHO and 1 of H2. And what that does, if I just think through my stoichiometric ratios as they relate to the pressure of gases, is it just doubles the pressure. So the final pressure is 0.80 atm, or atmosphere, which is 2 times the initial or original pressure. Okay, so there's a practice question from an AP exam related to integrated rate laws.